Do you know whether space satellites exist or not?
When it comes to hurricanes, research has come a long way to help predict when and where a storm will hit.
They don't use outer space to do it, and they draw it up with CGI.
And an instrument called HIRAP will investigate the strength of a storm. The HIRAP instrument will fly aboard an aircraft to study storms from the very large down to the very small scale.
And because those smaller scales tend to be much more chaotic and difficult to predict, and the interactions between those smaller scales and the large scales is far more complex.
It's complex because the smaller scale storms can be directed by the government.
The High Altitude Imaging Wind and Rain Airborne Profiler, or HIRAP, is a radar designed to examine the factors of storm intensity.
The HIRAP Doppler radar is a dual frequency radar, so it has two frequencies that measure at two different angles, and as the plane is flying, it's sort of scanning in a cone. And as it's flying over a particular target, say the eye wall of the storm, by scanning in a cone, it looks first one way and then sees the storm from a different direction. And that's what allows us then to measure the three-dimensional winds and precipitation within the storm.
Because outer space satellites do not exist. There is no such thing as orbits.
To get an accurate read on precipitation particles, like rain or ice. The signals that bounce back reveal the type, size, and distribution of rain or ice particles, as well as how fast the particles are moving. The speed of the particles can help determine the wind and circulation in a storm. HIRAP will provide scientists with years of unprecedented data that will allow them to decipher the formation, structure, and intensification of hurricanes.
And after all that, this graphic, and when they talk about it, will be credited to outer space satellites orbiting a spherical Earth, none of which exists. Outer space, orbits, satellites, and the spherical Earth. None of those things exist. So speaking of things that don't exist, these re-entry events don't exist. Nothing orbits in outer space. So when they say that a capsule is re-entering Earth's atmosphere and burning, doing the re-entry burn, and that may mean the burning of the rockets on board, but it also means the burning of friction as it slices through the atmosphere with searing heat and at thousands of degrees, enough to melt steel. I'm going to show you why that's not true. What is true is they drop these capsules out of airplanes with parachutes already deployed, you know, like strung and just dangling. It just falls out, parachute already hanging behind it. There's no heat. It's not hot. It's actually really, really cold because you go up any amount, a couple thousand feet, it gets pretty cold really fast. So what you have here is HD, clear, the kind of video you would expect from NASA for everything that they do, because you're paying for it. They shouldn't keep secrets, nor should they send grainy potato quality. It's like it's projected on a potato. It's like 90p or 240p at best with edits. It's CGI to begin with, and it's got like 4 colors and grainy as could be, and the frame rate of like 4, and you know, just horrible. But then this video, this is great. They don't have the fisheye lens. You see the flat horizon and everything, and that's because everything in this is real of what you see. This capsule probably is just empty inside, you know, like pretty much all of them would be. And even with just dropping it out of an airplane, you can see how much trouble they have just getting the thing in a boat. And you know that they drop it out at a specific location, because otherwise, how in the hell could they find this thing? Honestly, how could they find it? If an airliner goes basically missing, when you fly intercontinental from North America to Europe even, every time you do that, your airliner is like Malaysia, whatever that flight 370 or whatever it is, it totally goes missing. You go missing. There's no communication. They don't know where in the heck you are. they're putting up buoys, to track things like that. So the only way they can even find these capsules is if they were dropped in a specific location. It's probably not even that far offshore. It's out of sight, but that's how they do it. So this is 2018, and I think this is the year. They say it every year, but if I'm to believe them, then it's been delayed 3 years, 4 years, 5 years. This year, supposedly, they're going to start tracking airline flights between North America and Europe for the first time ever, because satellites don't exist. So supposedly now they're going to track them because they're putting up the cell phone towers on buoys along that path. So I don't know if you've heard of Kistler Aerospace. I really haven't, but this video is very illustrative. So here's a design. Excuse me. Oh, I'm still waking up. Okay. Here's a design. Okay, if I designed, actually I did as a child, I designed something like this, just drawing, like Simon. Hello, my name is Simon, and the things I draw come true. I like to make drawings. And so I made drawings like this, and I didn't go over the garden wall with you, but I did draw something like this, and it made sense. It made sense. It was not top heavy, and then it was aerodynamically sensible. Okay, so this shape is very sensible. The problem with this would be the spinning, but you could have retrograde rockets and all that. But reminds me of Dr. Evil's thing or whatever. But anyway, yeah, this makes sense. Now, this is the complete opposite. See how it comes down? It would not come down like that. I mean, I guess it's kind of like a water droplet, but think about it. If you drop something like that, because the wind resistance will matter more than the center of mass, or center of weight, actually. Mass is, the Catholic Church service. That's what mass is. Newton's mass is just weight. It's just. But anyway, yeah. So it would go down upside down and poke through that trampoline. But that's actually a good idea, that trampoline thing. I think SpaceX co-opted that idea. But that would make sense to have that cone the way it was when it was going up. Now, if you drop a cone or any object that has any kind of aerodynamic form, one way or the other, it's going to orient in a way that would make sense. For example, you take an arrow, like I was going to say Peter Pan, like William Tell, bow and arrow. You got an arrowhead on one end and you got feathers on the other. That's the complete opposite of these stupid SpaceX rockets. They have to laugh at how stupid people are to believe. I mean, sure, anything's possible if you manipulate it and everything like that. But why would you design something that has a natural tendency to orient a certain way and then have rockets force it to orient another way just because? Think about that. It'd be like you shoot an arrow from your bow, and you have the feathers on one end and the arrowhead on the other, but you're using little tiny jet rockets to force the arrow to spin around backwards the other way and hit ass end first. That's basically the design here. That's how stupid this is.
Look at that, y'all.
During testing, crew members on the ground will monitor the status of the spacecraft's return to Earth, but they will temporarily lose the data connection because of the plasma's extremely high temperatures. The onboard jets continue to maintain the proper orientation for re-entry into the Earth's atmosphere. while the heat shield, which is the largest of its kind ever constructed, protects the rest of the vehicle. Finally, Orion will deploy parachutes in stages to gradually reduce the speed until it reaches a safe landing.
Just look at this cone-shaped thing come out. This is what they do every time. They litter all over in the ocean and everything. But anyway, so the thing naturally does not want to fall the way that they say that it's going to fall. It is going to try to turn over, and they've attached the parachute basically to the wrong side. And this is exactly what I'm talking about. It's like an arrowhead dropping, and the arrow wants to turn over. See, it's rolling, it wants to turn, and it's rolling, it's got some momentum, but you can tell it's either going to spin out of control or it would stabilize like sideways or pointing the other way, because this one's kind of flat, but it's just, you know, obviously this such a disaster here. Now when I found this video, it led me into the next one that I'm going to make, which will blow your mind. At least it blew my mind, because I could tell it was real NASA footage. I mean, some of it they've doctored up and made fake and altered it and everything, but man, I hope nobody was in that thing. But it was having to do with this type of thing, because the capsules, you know, the capsules are more cone shaped. So here I'll show you how kids know how cone drops.
Share with you a simple lab investigation that I've done with middle school students. It can even be done with elementary school students. Well, we saw that flight wasn't very stable. So what I'd like to do is I'd like to change this slightly. Now, the line that we cut, we're simply going, so let's try that. Okay, so now we see the cone is a lot more stable than just the flat circle that was falling. So here's the investigation. What can we do to the cone? What kind of changes could we make that would either make it fall faster or slower? That would be a problem that I would present to my students, and then I would have them get into groups of 2 or 3, and they can brainstorm about how they would go about testing various variables, what kind of things we could change. What kind of things could we change? Well, we might look at changing the weight of the cone.
Cones can be made heavier by adding something small to it or simply stacking more than one together.
We might change the angle of the cone.
Smaller angles to bigger ones can be measured fairly easily.
To do that, I've actually made these cards up, which we could use. There's 30 degrees and 45 degrees, 60 degrees, 75, 105 degrees, 120, 135. That's probably about as wide as we can make it. Anything wider than that, it starts becoming unstable.
Unstable like this. Middle school science class, an average middle school science class student knows better than this, than what NASA does.
We could try changing the size of the circle. We could make them very small and make the cones a small circle. We could make them larger. This size, we could make them extremely large. We could change the type of paper. For example, we're making it out of, this is actually just copy paper. We could try magazine sheets, we could try newspaper sheets, we could try wax paper.
We do measure the cone's weight and then adjust them just to make sure they all weigh the same.
We might change the cone by putting holes in it. Another possibility is you can cut slits into the cone. For example, I'll put one here, and I'll put another one here. If we then bend the paper back a little bit, it would actually make little wings on it so that when you drop it, it would actually turn. Cone fall to terminal velocity, or at what height does it reach terminal velocity? So we might try it at various different heights. Time it, measure the distance, calculate the average speed, set it up a graph, and then look for the graph to level off at a certain place. So that's my experiment for today. All right, thank you. Bye.
Now it's deeper into space than ever before. It will be launched into Earth's orbit as part of the Exploration Flight Test 1, meant to collect data for future manned missions. Orion will return to Earth after spending around 4 hours and 25 minutes in orbit. Jets will be used to properly position Orion before it enters Earth's atmosphere 75 miles above the surface, traveling at over 20,000 miles. Per hour, it gets so hot that plasma forms at 4,000 degrees Fahrenheit in the air particles around the spacecraft.
This may be the most dangerous part of the flight.